Alright, in this video I want to discuss the polar coordinates of a complex number. So suppose I have an arbitrary complex number of z is equal to x plus I y. So this complex number will have the coordinates of x and y on the complex plane or the argand plane. And then I can draw a vector from the origin to this coordinate to represent this complex number visually. And this vector will have a length of r and an angle of theta with respect to the real axis. And we know, just as in plane geometry, that it will have a height of y, a horizontal component of the length x. So by Pythagoras' theorem, the length r is equal to the square root of x squared plus y squared. And we can also brand this as the modulus of z, or the magnitude of z. And the angle theta by trigonometry is simply the inverse tan of y divided by x. And this we call the argument of z, written as argz. And also by trigonometry, the horizontal component is simply equal to r cos theta, and the vertical component y is equal to r sine theta. So z, the complex number, can be rewritten as z is equal to r cos theta plus I times r sine theta. And here I can factor out an r, so I get r outside of cos theta plus I sine theta. And this expression here can be abbreviated to CIS or cis theta. So z can be written as z is equal to r cis theta, or you may see it written as mod z cis theta. And this is what we call the polar form of the complex number, or we can also call it the mod argument form. Alright, let's do an example. Let's write z is equal to the square root of 3 minus I in modulus argument form. So if the square root of 3 is approximately here on the real axis, and negative 1 is here on the imaginary axis, then z would be located at the intersection of these values. Then if I complete the picture by drawing a vector from the origin to the point, this is my vector representation of z. So the modulus of z, or the magnitude of z, is equal to the square root of x squared plus y squared, which in this case is equal to the square root of root 3 squared plus negative 1 squared, and this is equal to the square root of 3 plus 1. 3 plus 1 is 4, and the square root of 4 is equal to 2. Now for the angle theta with respect to the real axis, we have to be careful here, because we could either go all the way around in an anti-clockwise fashion, in which case the angle would be positive and it would be a reflex angle, or we could go in a clockwise direction and express the angle as a negative angle. In this case, I believe it will be more appropriate to express the angle as a negative angle in the clockwise direction. So we can write the angle theta, or the argument of z, is equal to the inverse tan of negative 1 divided by root 3. And this equates to a value of negative pi on 6 in radians. Or if we wanted to express the positive value of theta, we could say that theta is equal to 2 pi minus pi on 6, which is equal to 11 pi on 6. So finally, the complex number z equals root 3 minus I can be written as 2 cis or cis negative pi on 6. So I hope this video has helped you better to understand the polar form of complex numbers. Please give me a like if you found this video useful, and please subscribe to my channel for more helpful maths tutorials. In the meantime, best of luck with your math studies, and thanks for watching.